Anybody?
I did the parallelogram and the rhombus.
Okay. What else? We did parallelogram and rhombus, right? We studied about the properties of rhombus. How does it differ from a parallelogram, right? What else? Do we all remember the properties of rhombus? How does it differ from parallelogram? Can you please refer your notes and just get back to me? That this is what the key points are. But I see there is a lot of less attendance today as well. Yes, anybody? Key important points of rhombus when compared to a parallelogram. Please refer to your notes. Please go through it. Tell me what you remember, what you have written in the notes. Yes, nobody remembers? That's not good. Anybody still remembers from their notes? Rhombus. I'm asking about some properties of rhombus, guys. We discussed about rhombus in the previous session or not? Or we discussed something else? You can say, I don't remember, sir. That's okay. But
Diagnosed by
yes, what do we remember?
All the sides are equal.
All the sides are equal. Okay. What else?
Diagonals bisect at 90 degrees.
Diagonals bisect each other. Okay, good. What else? Diagonals intersects at 90 degree. Do we remember that? No. I forgot. Okay, so we forgot that. Okay. Do we all know that at least that in rhombus the diagonals will intersect, making 90-degree angles? Do we all understand that?
Yes.
How about others? Just 1% said that. How about others?
Yes.
Yes, sir.
Okay, we get that. Okay. What else do we know about rhombus? Rhombus, as usual, what is the area of a rhombus? How do we define? Anybody? How do we define the area of a rhombus? Anybody?
D1 times D2 divided by 2.
What is that, Sanjo? What is D1? What is D2? You can say, I'm not too sure, but this is what we had. Anybody?
Sure.
Okay. Others, please.
The length of the diagonal.
Length of the diagonal. Are you sure?
Yes, I'm pretty sure.
Okay. What else? Do we all remember that the area of a parallelogram is base multiplied by height? Yes or no?
yes, sir.
Base multiplied by height, right? How do we get the height of a general parallelogram? How do we get that? Is there any direct formula? Is there anything that I can do to find it? Or it depends on the problem? Not so sure, right? Okay, for the height of a parallelogram, it depends on what kind of problem you get. Area will always need a height. Height is one side which is 90. There's no other way. Do we all get that? Clear?
Yes, sir.
Okay. At the same time, area of especially rhombus can also be found using diagonal lengths. Okay. D1 and D2 are nothing but the diagonals. If you have the diagonals, then also you can find the area of the rhombus. Are we clear? So far, are we in sync? These are the key properties that we have to understand. We have understood it, there is no doubt about it, but we have to solidify it, saying yes, we know what is going on. Okay. Now, this is one of the simple problem about rhombus. Did we discuss this problem earlier?
Yes.
Okay. Do we all remember how to solve this? Guys, if you forget things, then I have to repeat it. If you repeat it, if we keep repeating things, then we'll not be able to finish our syllabus and our coverage on time. Okay. So guys, you have to either say me, sir, we have not understood this problem, or we know about this problem. At least the ones I covered in the class, you have to remember. At least in a week's time, you should remember. If you are not clear, if you are thinking that, okay, sir, I wasn't clear, we will discuss again. But you have to be, at least tell me. Did I bring this problem in discussion? If so, yes. If the answer is yes, you should be able to tell me, sir, this is what we have discussed about this problem. This is how we solve it.
I remember this problem.
Okay. How many of you don't remember this, please?
I don't remember.
Okay. Others?
I do not remember this one.
Okay. Anybody else?
I don't remember either, sir.
Okay. Okay. For those who don't remember, take a fresh look on this problem. Try to remember from your notes that there are ways to find areas. There are ways to find the side length. We have Pythagoras theorems available with us that defines hypotenuse, perpendicular, base, helps us to find the side length. So please think about what rule can we apply to get one side of the rhombus ABCD. If you can find one side, the other side is already available to you because they are all going to be same. Question is, AC length and BD length is been given. How do you find the side? Take a fresh look at this problem, guys. If you have forgot, that's okay. But please think about it and tell me that, yes, sir, this is what I'm thinking. This is what you are thinking. And we can sync up. Science, Harsh, how is the problem category for you? Hard?
It's kind of easy. We could use Pythagoras theorem.
Okay, we can use Pythagoras. Okay. Others, please. Srinitya.
This problem's like medium for me.
Any thoughts you have how to proceed?
No, not really.
Okay, Aditya Chobe.
I think this problem's kind of easy.
Okay, what should we do in this one?
So, when it comes to the lengths, I would do AE as 9 and DE as 12. And then I'd do 9 squared, which is 81 plus 144, which is 225. Root 225 is 15. So the
Okay,
side
very
is
good,
AE.
Aditya. How many of you think that Aditya has given the right steps, or you kind of follow the same steps?
The
Or
same
you're
thing.
not
Yeah, I
clear?
think he gave.
Yes, go ahead.
That's what I got too. So I think it's right.
Yeah.
Okay. Okay, just so that everybody understands this problem well enough, I'm going to just make a clear-cut explanation here. Since AC is 18, the length of this side is going to be 9. Okay. All you need to just make it this as it to be written as 9 first. Okay. This length is going to be 9. Now this length is 9. Another one, if you see, BD is equals to 24, which means BE as a length, total length BE is going to be 24 by 2, which is going to be 12. Okay. Now that you have 9 and 12, and you already know, guys, here is the key point. You already know that you have got 90-degree rhombuses bisects at 90 degrees. So you know that this is going to be 90-degree directly. Okay. So you know that you can apply the Pythagoras rule in triangle AEB. So you would say that AB is equals to square root of 9 square plus 12 square. Okay. That is going to be our main concept here. Okay. So I am going to say this is square root okay, square root of 9 square, 9 to the power 2 plus 12 to the power 2. Okay. And the total square by Pythagoras rule. So you will get the AB side. Making sense? Yes, no? You'll get the side. Okay or not okay? Anybody who was not clear? Anybody who was not clear? Anyone who is not clear, guys? Okay, so I am thinking everybody is clear about this problem. Let me see if I can bring some more quadrilateral related problems, or else we'll start with a new topic. Okay, here is something that I have for just a simple square and triangle related problem. Okay, let's take a look. It is interesting, definitely I feel so. Okay, let's see if anybody can really get me some answers about it. It's a square which is in front of you. A, B, C, D. Side length is 12. BF has already been given as 4 to you. What is the length of BE? There are some conceptual things that you have to apply. It is more of a quadrilateral plus triangle concept within a single problem. Your quadrilateral here is actually a square, which is ABCD. And the ask is to find BE, okay, which is technically a side within a triangle. You have to think what kind of relationship you can make. Tough problem? I would say yes, it is a tough problem. Not that
I
easy.
wouldn't say it's tough.
Okay. Okay, guys, here is the one thing again I want to revisit. Do you think in my class, we are discussing a lot of tough questions rather than middle level questions, or I should be bringing up something that is easier? Do you think like that? How many of
Yeah,
you think like that,
it's
honestly?
tough. Most of the time, it's tough.
Okay. One person says it is most of the time tough. I want to hear back from others as well. Whether we
Yeah, I
should be
think like sometimes it's easy, but like a lot of times it's tough for me.
how do we want to do it? Do we want to continue going with some tough, challenging problems, or do we want some more simpler problems to discuss in the class? That is what I'm trying to get into.
I would want tough.
What was that?
I would want tough problems.
Okay. One person only and saying that I want continue like this, tough problems. Others, please.
I agree. I think we should continue like this.
Okay. Sanjo, how about you?
Yeah, I would like to continue doing further.
Aditya Chobe?
I guess these type of problems are good, yes.
Okay. Meenakshi?
Yeah, I would like to continue tough problems too.
Okay, so nobody wants easy problem to deal with. Okay, fine. So guys, here is one good part about, like, I can tell you one thing. Some of my old batch students that I've taught in like past 2 to 3 years, I have always taken their feedback on after they go for the SAT exam, after they have appeared and they come back. One of the most top ranker who has scored more than 1500 out of 1600. Some of them are like, few of them has already told me, given a feedback that, sir, the best part of your studies are, you are always teaching and starting with basics and going up with the standard of the problems. So when we learn about these kind of problems, the SAT problems that we get, where I have seen, is comparatively either of similar standard or less than that. So I don't get surprises, I don't get fear out of it. And that has helped me a lot to gain confidence and a very good score. So your standard is very good. You should continue to, whoever wants to have a very good score, they have to raise their standards. You don't raise their standards, going simple questions and all, you won't work actually. I know that some of you might be feeling, oh, it's a trouble to get such a high standard all of a sudden, because you have to have a very good basics for that, guys. If you are not having good basics, you won't be able to catch up with my classes. I'm very honest with you. Okay, so yes, if somebody is facing problem, please talk to me personally. I will try to help them. Okay, I still want to ask one more question. Anybody other than Steve is in Delaware in this entire batch? I was expecting 1 or 2 students to join today. I don't know what happened to them. Maybe because of the Thanksgiving. Okay, anyways. Okay, coming back to this problem. Any thoughts? I will give you a hint. You all have studied congruent triangles and similar triangles. Congruent triangles are mostly, you can say, same triangles. But similar triangles are like small brother, big brother relation. Okay. The sides for similar triangles always are in proportion. Here you have to apply a similar theory. That's all I have. Now you can think of like what could be that.
I think if we find AF, I think that would help. And we can do that using the Pythagoras theorem.
Okay. How? How will we find AF?
AB is 12 and BF is 4. So the hypotenuse is AF, which makes it root 160.
Okay. 144 plus 16, root 160. Okay, got it. But I'm still not sure how do we get BE.
Isn't there a rule that says like AF times EB equals AB times BF?
Okay.
Can we use that rule?
AB times
AB times BF equals AF times BE.
okay. How does it rule comes? If you are saying about any rule, you have to get it backed up by some theory, some logic, isn't it? Otherwise, difficult. Anybody else wants to give it a try? Anybody else? No? Nobody wants to give it a try? Okay. I'll try to give you some hint. Okay. And then let's see if you guys are clear about it. Okay. Do you think that triangle AEB and triangle BEF are similar triangles? First thing, they are similar triangles or not? That is the first thing I'm going to ask. Why?
No.
Okay. Why do you think it is not true? I'll prove it. Okay, let's prove it. So, very simple thing I am going to apply here as a logic. I am going to say first angle which is going to be same. Okay. Is this angle same as this? Yes.
Yes, sir.
Do we know that the diagonals when they of a square, when they are joined, they make a 45-degree angle here? This is a 45-degree angle.
Yes, sir.
So this and this are same. It is a 45-degree angle.
Yes,
Am I
sir.
making sense? 45-degree angles. Okay. If this angle is equals to this and this angle equals to this, then this angle has to be equal to the other one. This angle has to be equal to this angle or no? If two angles of a triangle are already same, okay, and they are attached, the third angle has to be same, is it not? Because they all sum up to 180 degrees. Make sense? No?
It makes sense, sir.
Okay. That is clear, right? Now we will talk about something like how to apply that. I am going to apply a different theory here. How? I am going to say that these similar triangles, their sides will be in proportion. Can I say that? Will their sides be in proportion?
Yes, sir.
Okay. Are we all okay with that? With that property, the sides will be in proportion? Yes. So can I say AD by BF is equals to DE by BE? Not so clear. See, what I have done is I have simply applied the rule AD, which is this side, okay? AD, which is this side, by this side, okay, is equals to DE, which is this side, by EB. So what I've done is I have just compared the two triangles and made it in ratio. Sides ratio. Anybody who like is totally lost here in this particular criteria? Anybody?
I'm not lost, but I was just wondering, like in this, even though like it looks obvious from the picture, you're just supposed to assume that like BD is the diagonal of the square.
Okay, let's elaborate by this triangle relationship. They are similar triangles. In these similar triangles, how do we define the relationship? Do we say that AB by DE is equals to BC by EF? Do we say like that? We can say AB by DE. See, AB by DE is equals to BC by EF. If they are similar triangles. Another way of saying that is AB, which is this side, by BC is equals to DE by EF. Whatever you want to say, this is also applicable. Another way of saying is AB multiplied by BC is equals to DE multiplied by EF. Whatever rule you might want to apply, that is all okay. There is no problem at all. Am I making sense? Yes or no, please?
Yes.
Okay. So in this case, AD is 12, BF is 4, equals to DE. I don't know what is DE. I am going to put DE by BE. Okay, but what I'm going to do here is I am going to add a +1 both sides. So this becomes 12 by 4 plus 1 is equals to 3 plus 1 equals to DE plus BE. DE plus BE by BE. Because see, I added 1. So I'm just making it like a proportion. Just added 1. So BE will go at the top. If you want to just say it like this is B by B, that is also works. You will get that. 4 equals to DE plus BE. If you see DE plus EB is actually BD by BE. Because DE plus BE is nothing but the whole segment, which is BD. BD is equals to 12 root 2 by BE. Why this is 12 root 2? Anybody? Why BD is 12 root 2?
If you were to apply the Pythagorean theorem, I think.
Sorry. Meenakshi, can you explain it to everybody how you got 12 root 2? Go slowly. Explain it to everyone. You are right.
Yeah, so the Pythagorean theorem is a squared plus b squared equals c squared. And in this case, so basically the adding the squares of the sides, so or the legs rather. And here AD is 12. And because it's a square, you know that AB, which is the other side, is also 12. And so you can find the hypotenuse by doing 12 square plus 12 square equals the hypotenuse. And then you would square root that on both sides. So I believe you would get 288, like the square root of 288. If you did that, and then if you were to like simplify that, you would get 12 root 2.
How many of you got that? Okay, I am still hoping that you guys in flow. Now, dividing both sides by 4, this is 1 time, this is 3 times. So finally you get BE equals to 3 root 2, and that is your answer. Now guys, this is, to me, it's kind of, I can say that it's a legitimately a high standard problem. I can tell you that much. It's not that of an easy problem, but I wanted to show this problem to you too, so that you guys understand that how to apply similar triangle rules. If you do not know that, it's probably very difficult to get this solved. This is a classical example where you need to understand the concept of similar triangles, how to apply the proportionate theory to be able to find the sideline. Plus, it's a mix. It's a triangle within a quadrilateral. So this is altogether a different type of problem. Okay. And also at the same time interesting. I feel it is interesting problem because we use a lot of things, a lot of properties. We had a revision of similar triangles in this case. Application of the proportions of the sides that you can think of, that also we applied. So we are good. I mean, this is a good problem to me, but equally it is not that easy. It is above medium for sure. How many of you got that sense, at least got some idea about what is happening here? At least 70% maybe?
Yes.
At least 70% understood, sir. This is what trying to see, like, what do you guys think? Yes?
Yes, sir.
Okay. Others, please.
I got it. So I was just confused. So here we proved that AED and BEF are similar, not AEB, because that was what I was confused. Okay, thanks.
Others, please. At least did we get 70% of the problem? That yes, sir, I got some 70%, around 70%. Understood.
Yeah, understood.
How many of you think that, sir, this was a really tough problem? I want to do these kind of problems again. Anybody? Okay, guys, without wasting any further time, I am going to pick up some more quadrilateral questions and let's see if we can solve this. Okay. Did we discuss about this problem, guys? Anytime? Anybody? Anybody thinks we have done this problem before? Anybody thinks we have done this problem before?
Yeah, we've done this problem before.
Are we sure that we have done this problem, guys? Now
Yes.
maybe some people are forgetting. Sorry, I am also forgetting. But guys, for me, the problem is I deal with this kind of questions with many batches, so I just don't remember it. That whether I have covered this problem for your batch or not. That is my problem. And fortunately, what's happening is like in the other batch also, I'm running plane geometry. So I don't remember whether I have discussed in this batch or that batch. Okay. Do you want me to switch to another problem, guys? Do you think that we have covered this problem? So one person said that, sir, we have discussed this. How many of you want me to jump onto another problem or stay with this problem and try to see what's going on in here?
I think we should do this problem.
Okay. Okay, let's do this problem. How many of you think this is medium to tough? It's not very easy, I feel. Medium or tough or a hard problem.
I think it's like somewhere between medium and tough.
I think this is somewhat pretty easy.
Easy, okay. Good thought. What about others?
I would say it's between medium and tough.
Okay. Okay. Others, please.
I think easy.
Okay. What kind of logic should we use here? Let's think about that first. What logic do you think we should try to apply here? Or anybody has any initial thought? Anybody has any initial thought to share?
I think initial thought is that the triangle, trapezoid could be split up, the quadrilateral can be split up into 3 triangles.
Any advantage with that?
Yes.
Okay. What is the advantage I'm going to get if we divide it?
Then we're just gonna get like 3 triangles with each of an area of 50.
How do you
Which
say
is
that the
big.
areas, triangles, areas will be all same?
Yes, they will all be the same since
Why?
the triangle is I can say just by looking at it, it's more because it says the T is the midpoint of PQ, making if we flip the triangle, it'll also be the exact same on RTQ or RQT.
Okay.
So that just leaves the SRT, in which that case would just be the exact same triangle.
Okay. Others, please. Anybody?
I think there's a I did this a different way.
Yes, sir. Tell me.
So so the area of PST is 100. So I drew a line from the middle of PT to S to find the height, which would be 10, and then PT would also be 10.
How?
Well,
How it will come as 10?
would PT, I just assumed PT would equal the midpoint of PT to S.
Okay. That is the T is the midpoint. PQ's midpoint is T. That is okay. I agree with that. But how did you confirm that it's going to be 10?
Because I just thought that any other factors of 100 wouldn't make much sense.
Well, don't assume A, B, C, D, what is going to make sense and what is not. Try to, let's say you don't have A, B, C, D options. How do you solve it? That's what you should think.
Okay.
Okay. There are two ways of doing it. Okay. Let's try to think what is the not so healthy way. Okay. We know that there is a quadrilateral. Okay. Did we call out that triangle quadrilateral PST is the midpoint if the quadrilateral PST? Okay. Did we say that PST is an equilateral triangle? Did we say anything like that? No. There is no say like that. But that is said that ST is parallel to RQ. That is very clear, right? ST is parallel to RQ. Okay. And PST, T is the midpoint of PQ. Okay. So I will tell you one theory. I am going to add this straight line and make it join with R. Okay. Are we clear? Yes. Are we clear? We just added the T and R points. Okay. Now, if I take, we know that the area always need height. We all understand that. That just what it needs is, it needs the height. If we are getting the height, my problem is half solved. That is the first important key thing that we have to remember. Height for this triangle PST is this one. Height for triangle SRT is this one. And height for TRQ is this one. All the heights are same. There is no difference in the heights. All length of the heights are same. Okay, that is very, very clear. When you have heights equal and base also equal, then the areas are going to be same. If the height of two triangles and the base of two triangles is same, then the area will also be same, which is half into base into height. Am I making sense? If two triangles have same height and same base, and area formula is half multiplied by base multiplied by height, is that going to be same area triangles or not? No? Silence. What happened? What I'm trying to say, again, I'm repeating. You have two triangles. Okay. Like this. This is equals to this. You know that this height is same as this height. Okay. And this base and this base, okay, is same. It's already said. Okay, this and this is same. Height is same. So isn't that the area of this triangle is going to be equal to this triangle? Yes or no? Not clear?
Yes, sir.
1% said yes. What about others?
Yes.
It sounds like quite a not so clear environment for this problem.
I'm
Okay.
clear, sir.
You are clear? Good. Guys, here one simple logic we are going to use is, somebody has clearly said 50 centimeter square is the area of PST. then the other quadrilateral will be divided into two halves and with similar areas. Answer is 150 centimeters square. That is correct. 50 multiplied by 3. That's all. And you're done. How you are getting is the logic is this. Because the base and height remains the same, your area will remain same. This is the entire shortcut basically. Does anybody has any confusion, guys?
I was confused. How do you know that the top area, the SR is this, the base of that, like the height of the length of that is the same as TQ?
Very good. How do we know that? That PT is equals to SR. How do we know that? Good question. And that's a good catch as well. I believe it's a good catch. Okay. The answer lies in the logic ST parallel RQ. We have already mentioned ST is parallel to RQ, right? Did we mention that? It is already there in the problem, right? PQ is parallel to RS, already mentioned. So, is SRTQ, I repeat, SRQT is a parallelogram. Parallelogram has opposite sides equal. Parallelogram has opposite sides equal. Am I making sense, Meenakshi?
Yeah, thank you, sir.
Okay. A very good observation. Anybody else here? Not clear. Why it is that RS is equals to TQ? Because it's a parallelogram, opposite sides will be equal. If opposite sides are equal, height is same for all the three triangles. All the three triangles height is same. So the area for each of the triangles is going to be same. So 50 centimeter square, 50 centimeter square, another 50 centimeter square, 150 centimeter square is my ultimate answer. And we are done. Are we good? Okay.
Yes.
Okay, let's try to bring up one last problem for today, guys. I know everybody was kind of like, oh, we want to be done. Okay. Do we remember that we have dealt with this problem? I think we have dealt with this. Yeah, I think we have dealt with this at least. Let me see if I can bring up something. Okay, we are going to discuss about this trapezoid now. Okay. Trapezoid, guys, here is the thing. We discussed about rhombus and right. We haven't discussed much about trapezoid. Have we discussed about much about trapezoid yet? Anybody remembers anything about trapezoid discussion?
I think I know how to find the area of a trapezoid.
Okay, but have we discussed about trapezoid, guys? Any special properties we talked about? Okay. Trapezoid doesn't involve too much of theory, guys. Very plain and simple. It doesn't involve too much of, and we don't have to really get into too much of like theory here in trapezoid. It sounds, I mean, if you remember the key things, it's easy actually. What is actually trapezoid? Only remember one thing. In a general trapezoid, only one side is parallel. What did I say? In a general trapezoid, only one side is parallel. That's it. It is not a parallelogram.
Can you repeat that?
One side is parallel in a trapezoid. Only one side. So that means this is a typical, this could be a typical trapezoid. Like this. Okay. Let it be a little more shorter. This could be a typical trapezoid. A, B, C, D. If you get this and this parallel, this is a trapezoid. Done. I don't have to think otherwise. As long as in the quadrilateral, one side is parallel, it's a trapezoid. Another point of understanding is, if in the same category, if I have something like this, okay, A, B, C, D, and if the length of AD is equals to BC, I repeat, if the length of AD is equals to BC, then this is isosceles trapezoid. That's all. But in a typical trapezoid, one side is parallel and this is just a trapezoid. That's it. No other criteria needed. And we are done. One side parallel, trapezoid. Done. Isosceles trapezoid, one side parallel and opposite sides, one of the opposite sides are equal in length. That is isosceles trapezoid. Isosceles means two sides. Done. If you remember one more property, if you can, then try to remember that if we have a straight line passing through like this, now these two are parallel, this is also parallel, let's say, with these two, then the proportion of this by this is equals to this by this. Similarly, if these two are parallel and I cross like this from the middle, then this by this is equals to this by this. That's all we need to remember for now. Now there is a lot of theories like how to find the area of the trapezoid, this, that, diagonal, median length, this, that. Don't go for that for now. For now, we have to know that, but for now, don't do it. Okay. One more thing that also applies. In parallel lines, we studied that when you have a parallel line and there is a transverse, then this side plus this side makes up 180 degrees. Right? We learned about this. Did we learn about this? Do we all remember? Yes and no, please. This line is parallel to this line. This is a transverse. This is the transverse. So this side, this angle plus this angle equals to 180 degree or no?
Yes.
Okay. So in this particular problem, if AB and DC are parallel and this is a transverse, so can you say that this angle plus this angle will be A together will be 180 degree? Yes. Anybody feels this is correct?
Yes.
Okay. Now take a look at this problem. And I won't answer it. You should be able to answer it.
Since we have B, like the angle of B to be 123, and we have to find C, couldn't we subtract 123 from 180 to find C?
Do we agree with him? Do we agree? Yes. Anybody else? Angle B is already given 123 Angle D is already given 75 degree. What is the measure of angle C? Akanksha. Measure of angle C.
Sir, we can just, since it's parallel lines, we can do the corresponding angles, so we can subtract 75 from 180, and it's 105.
Are DA parallel to BC?
No, CD is parallel to AB.
Adjacent sides sum up to 180 degree only when corresponding sides are parallel. So can we, in this particular case, can we say that angle D plus angle C is equals to 180 degree? Can we say that? Angle D plus angle C is equals to 180 degree. Can we say that? No. Why no? Because AD and BC are not parallel. But angle C plus angle B can be together 180 degree. Why? Because AB and BC are parallel. Am I making sense? You have to choose the angles corresponding to the parallel lines, guys. You cannot just pick anything from two different. C and D cannot make up 180 degree. B and C, angle B and angle C will make up to 180 degree. Why? Because DC is parallel to AB. That is why C and B angles can be together 180 degree.
Yeah, sir, sorry, I said the wrong number. It's not 75.
Yes.
180
Are we
minus.
clear, Akanksha?
Yes, sir.
So now what should be angle C?
It's 180 minus 123.
Very good.
So it's
57.
57 degree is the answer. That is why this problem has been given, so that you guys have to understand what parallel lines we are dealing with, where is the angle that we are dealing with. Okay, guys, I don't think that we will be having any. I think maybe in the next class we'll discuss some more problems related to trapezoid, but then I will be jumping on to circles. Okay, please try to do your Wincast online worksheets, Khan Academy, QMath, whatever you want to, whatever worksheets available in the market. Please try to spend some time on the plane geometry portion, because we just kind of finished quadrilaterals, discussing about quadrilaterals. We have discussed rectangles, square. We have discussed triangles within the quadrilaterals. We just discussed about rhombus, parallelogram, trapezoid, isosceles trapezoid. You don't need to remember any more properties, any more figures like that. As long as you remember the key properties that we have discussed in the class, you are good to go. Please spend some time. Please try to practice some problems related to these areas. Okay. And then please bring back if you have any questions. Important aspect is, as long as you remember the key properties of these figures, you are still good. Even if you don't practice much, you are still good, but you have to remember the properties very, very well. Okay, spend some time, guys. Okay, and then we'll talk, okay, in the next class. Okay, thank you, guys. Enjoy the rest of your weekend. Have a good one. Okay, thank you so much.
Thank you
If
very
you
much.
do not have
Thank
any
you.
questions, please log off.
Thank you.
Thank you.
Thank you. Bye.
Bye-bye.
Thank you.
Hello.
Hello, Sign.
This is Sai Dad.
Hello, sir. How are you doing?
I'm doing great, sir. How about you?
I'm doing good, sir. Tell me, how's it going? How's
Going
your-
good. I've been planning to talk to you from long, and it's not happening. And we caught with sick like last 2-3 weeks.
Okay.
Continuous we couldn't. So I couldn't
Okay.
get on to classes or missed couple in between.
Okay. Okay.
So I just saw Flexi quiz. He has some pending questions which he hasn't done. I'll make sure he completes this weekend and get back to you on that.
Okay.
Uh,
How he's liking the classes so far?
Yeah, he's liking classes. Yeah, he's trying to. I kept him on the edge always. I say, okay, try to have some challenging questions. That's how you learn. And
Mhm.
more than doing the problem, you should know the